spent some more time just kind of working in our section 5.1 stuff. Did you, at this point, you hopefully have kind of worked on and or finished 7 through 14? Do we have any questions there on things? Landon?
It's more of just like, if you looked at when you were doing the problems last time in class, we had some questions.
Sure.
For number 14, see how you can cancel out those two signs? Is that because one is a positive and one's a negative?
Yeah, so I added them together,
Okay.
and they get 0. That's why they crossed them out. Yep.
Yeah, that was.
Oh, okay. Maria. Yeah. Sure. All right. So the directions say to rewrite this in terms of sines and cosines and then simplify. The first thing I guess I would do before I do any of that is look to see if there's anything algebraic to do. Worth noting that you can't reduce this because of the addition and subtraction going on. You remember we can't reduce part of an addition or subtraction problem. So I would just start by rewriting tangent as sine over cosine and rewriting secant as 1 over cosine. And there's really no way of avoiding having a yucky looking fractions inside a fraction situation, but that's okay. Maria, are you okay so far, so good? Okay. So right away I should notice that, hey, this is really nice that I have common denominators here, so I don't have to like worry about that piece. I can just kind of rewrite everything as one fraction. So I can have sine x plus 1 over cosine x over sine x minus 1 over cosine x. Yes?
Why don't you like cancel it out?
Why don't I cancel it out?
Yeah.
What would I be canceling?
When it's like a fraction, do they both have to be like the same positive and positive, or is it positive and negative? Like which ones do you cancel out again? Let's say to cancel it, if we want it to be positive.
You want to cancel like those things? Is that what you're saying?
No, I think it's like which ones do you cancel out? Like in a fraction. They're both the same.
If both what are the same? No. It's okay. Like I'm legit. I want to answer your question. I'm just not sure what you're.
Like sine over cos and sine over cos, can you cancel those two out?
No, and the reason I can't cancel them out is because they're part of an addition or subtraction problem.
Oh, but if they were multiplying.
If that was being multiplied,
Okay.
then yes, you could reduce those straight away. But if that was the case, we could have reduced the tangents.
Right.
Straight away at the beginning and the secant straight away at the beginning. That's what you're asking? Okay. Yeah, and again, any of these kind of what if questions, these are good things to ask, right? Like it's important to develop some intuition. Really the only way you can do that is like, hey, why wouldn't you do this thing? Or could I do this thing? And sometimes it's like, yeah, you can do that. I don't think it's going to be very helpful in this because of this, this, and this. Or, yeah, you could, and it's basically the same thing. It's no different than what I'm doing here. Totally fine. Or, no, there's like an algebraic reason why we can't do that thing. But again, like, this is the first time you guys are really doing these kinds of problems. You probably don't have a lot of intuition because they're all can be a little bit different. So, like, asking these kind of what-if questions and really pressing, like, hey, why aren't you doing this? Or, like, I would have thought to do this. Those are important things to ask, right? Like that's how you're going to kind of develop some intuition and get some idea of like what to do. So I don't mean to be frustrating. I just legitimately didn't, like, I was struggling with the vocabulary, understanding like what exactly we're talking about reducing, but like those are important questions to ask, and I don't want to make it frustrating, but I legitimately want to be able to answer those kinds of things. Okay, so everybody's happy to where we're at right now? So when I look at this, when I see a fraction on top of another fraction like this, what I'm really going to be thinking about is I'm going to think about this as like a division problem, because a fraction is really the same thing as division, right? So that's what I'm kind of seeing in my head instead of the big fraction, is I'm thinking of the division of two smaller fractions. Because this is something that I know how to deal with, right? How do we divide fractions? We make the fraction on the right the reciprocal and turn it into a multiplication problem. Everybody's okay with that? That's just dividing fraction rules way back from elementary school. So that's what I'm going to do next. So the numerator stays the same, and the denominator we flip. Which is great, because I see some stuff that can reduce. Even if I couldn't have reduced anything, this is still an improvement because it's now one fraction instead of like these stacked fractions. That's still going to be better, even if there wasn't any reducing to do. Though in this case, I can reduce the sign, or the cosines. Can I reduce the signs? No, why not? They're part of an addition or subtraction problem, right? So this is going to be as good as I can do. I'm just left with the sine x plus 1 in the numerator and the sine x minus 1 in the denominator. And that's realistically as good as I can do. Maria, does that feel okay? And this was a good one to ask about because we had this stacked fraction situation that we couldn't avoid. And we can, any situation where you run into where you have a stacked fraction like that, you could really approach the same way. The other option, or the other thing you could have done at this very first step, other than like adding the fractions and making common denominators and stuff, you could have also done this as your first step. You could have said, okay, well, I noticed that all the denominators are cosine x. So I'm going to multiply the big fraction by cosine x over 1 over cosine x over 1. This is still just 1, right? So when I distribute through, the cosine is going to cancel. So you'd be left with just sine x. The cosine over there is going to cancel, and you're left with just the plus 1. Same thing here. The cosines cancel. You have just the sine x. And the cosines cancel, and you're left with just the minus 1. And that's actually where we ended, right? That's usually a little bit quicker.
I have my foot warmers.
Oh, great. Can you just plop them up there?
Awesome.
Thanks, Bianca. Good luck this afternoon.
Thank you so much.
You're welcome. So that's that thing that I just showed you here, Maria. This is a nice trick. It's the same thing that we did over here. It just accomplishes it inside of like one step instead of 3 steps, but it's doing the same thing. And either way you want to go about doing it is fine. No big deal. Yeah. So this trick that I'm showing you here will work really anytime you have fractions inside of fractions. The only hiccup might be that what you multiply to the top and bottom might need to be more than just a single term. It might have to be like a product of a couple of things to get everything to cancel out. So it can get a little bit hairy to do all at once. But yes, you can do that anytime, and it works quite well. Landon?
So all you did was just multiply like each fraction by the reciprocal of one over cos.
So what I really did here is I looked at all of my denominators, and I thought, okay, what's the least common denominator if I were going to add all of these fractions together? Just cosine. So that's what I multiplied to the top and bottom, is whatever would be the least common denominator of all the fractions involved. And if you do that, all the fractions will clear out of there, and you'll end up with accomplishing the same thing you would have gotten if you made common denominators and then took the reciprocal and multiplied and reduced, and like it just kind of cruises through all those steps kind of in one. But if it gets like that's kind of a lot to deal with all at once, you can certainly kind of chunk it and do it the way we did it initially, which is probably really familiar feeling, as opposed to this, which was probably a new idea that kind of had a lot of stuff going on all at once. But either way is fine. You'll end up at the same spot. Victoria, I saw your hand up earlier. Was there one that you wanted to talk about also? 9? Sure. So 1 plus tan x over 1 minus tan x. So I would start the same way. The directions say to rewrite everything in terms of sines and cosines, because there's nothing I can do to simplify at the beginning, right? We can't do any reducing here because it's part of addition and subtraction problem, so we can't reduce just the tangents or whatever. So I'm going to rewrite tangent as sine over cosine. Feel okay? Do you want to make common denominators and add fractions and then do the reciprocal, or do you want to just kind of do the trick here? Let's do the trick. You want to do it both ways? Okay, we'll start with the trick though. So if I look here, I have 4 things, right? So I have to worry about 4 denominators. Really, these ones are just like 1 over 1. So like the denominator there doesn't really matter, but just to be clear, there is a denominator there. So if I were to add these 4 fractions together, I have 1 over 1 sine over cosine, 1 over 1 sine over cosine. The least common denominator would have to be just cosine, right? So let's multiply the top and bottoms by cosine x over 1. So when I multiply that to the 1, I get just cosine. When I multiply that to the sine over cosine, the cosines are going to cancel, and I'm left with just sine. And there's a plus sign in between them because the plus sign just comes with it. Is that okay? Same thing down here. I get a cosine, and then the cosines cancel, and I'm left with just minus sine. And that's probably, I think, as good as we can do there. Does that feel okay? Now, had you decided to go the other route, we would have had to make a common denominator in the numerator and a common denominator in the denominator. So hopefully it's pretty clear that common denominator in both places is just going to be cosine. So 1 over 1 would turn into cosine x over cosine x. Everybody okay with that? We're just making the common denominator. So if we add the fractions then, I'd end up with cosine plus sine over cosine in the numerator, and then cosine minus sine over cosine in the denominator. Still doing okay? And then we'll multiply or divide these two fractions. So the numerator is just going to stay the same. Then we'll change it into multiplication. The denominator we're going to flip upside down. So the cosines can cancel because it's a multiplication problem now. And we're left with then just cosine x plus sine x over cosine x minus sine x, which is the same thing that we had above, just with a few more steps. Does that feel okay? So again,
Even if like the other numbers are 1, you can take like the cos out. You know what I mean? Because like it's like adding and subtracting. Doesn't it have to also be cos to like take it out? Does it not matter?
Yeah, so it doesn't really matter. All you're doing is you're just looking at, I have these 4 denominators. Whatever I multiply by should just be the least common denominator that I need to add those 4 fractions. So whatever, it doesn't matter. I mean, if it was, instead it was like cosine plus sine over cosine, still fine because the denominator is 1. Nothing would have changed other than when we multiply the cosines together, we get like a cosine squared. But like, doesn't change how we would do things. It just kind of changes the result that we would get. Jane? Sure. That's absolutely. Let me go back and look at what 8 is. Okay. Secant times cosine over cosecant times sine. And I don't remember what the variable was for sure. I don't remember if it's like a u or a v or something else, but it doesn't, the variable name doesn't really matter as long as all the variables have the same name, you know what I mean? So the first thing we might look for is anything algebraic to do. Is there simplifying or factoring or anything to do? But there's not, right? Nothing is a like term, so there's nothing to do there. So I would just start by turning everything into sines and cosines. So secant is 1 over cosine. Cosine's already in terms of sine and cosine, so I'm just going to write it as cosine over 1 because it's being multiplied to another fraction. And that usually just makes it easier to make sure I don't do anything silly like multiply a numerator to a denominator or something, if I just write everything as fractions. Cosecant is 1 over sine, and the sine is already in terms of sine, so I'm just going to write that as sine over 1. And I love what I see here because I see a lot of stuff that can reduce, right? Those cosines can reduce, those sines can reduce. So I'm left with just 1 over 1, or 1.
I just forgot that we were solving in terms of like cosine and
Yeah.
sine. I put cosine as
Oh, you probably turn that to 1 over secant or something, and then you're just like, this didn't help me any. Yeah, Victoria. Sure. So 1 minus cotangent over sine minus cosine. So nothing algebraic to do, right? There's no like terms, there's nothing to reduce. It's all one fraction already. So I'm just going to start by rewriting cotangent in terms of sine and cosine. So cotangent is cosine over sine. You can't use a Pythagorean here because it's not cotangent squared. If it was cotangent squared, yes, I'd be looking at the Pythagorean square away, but it's just regular old cotangent. So far, so good?
Yeah.
And now I'm going to do my trick. So if I look here, there's really just one denominator. It's just sine x, right? So that's what I'm going to do, is I'm just going to multiply top and bottom by sine x. So when I multiply sine x to 1, I get sine x. And I multiply sine x to cosine over sine, I get just cosine. And down at the bottom, I'm just going to leave this as sine x times the denominator. And the reason I didn't bother to distribute the sine through in the denominator is I saw what I got in the numerator. And I noticed it's the exact same thing I had in the denominator. So I didn't bother to distribute the sine through. I just kind of left it out front as a common factor. Because what I'm going to do next is reduce there. Landon?
So you were able to do sine over 1 because there was only one denominator in like, the actual problem. So
Yeah.
Okay.
Yep, exactly. That's why I chose to do that.
So like if there's literally just one,
That's it. Yeah.
You
There's.
don't look at like the denominator.
Well, I mean, like all these denominators are 1,
Okay.
right? So they don't really matter. Is that cool? Okay. So we're just left with then 1 over sine x. And it said to write everything in terms of sine and cosine. So I guess that's what I would leave this as. You could also write this as cosecant if we're just simplifying, was the general direction, but that's what I would do here. Does that feel okay? Is it helpful, the amount of like narrative we're doing? Like trying to explain really the reasoning, what I'm doing, why I'm doing it, what I see. Jane?
Could you do 6?
Sure. No, this looks yucky. All right. So I have secant squared. Is it plus sine squared or just plus sine? Okay. And then what was the denominator? I've already forgotten it.
1 minus cosine.
Thank you very much. Okay. So again, nothing obvious algebraic to do. I'm probably just going to start by writing everything in terms of sine and cosine. So secant squared is 1 over cosine squared. And I'm going to write, since there's a fraction up there, I'm going to just write that as sine x over 1 so I don't get confused and do something silly. And then cotangent is cosine over sine. So there's that. Everybody's okay with what I did there? So let's do our trick. So if I look at my denominators, the least common denominator, if I were to try to add all that stuff together, would be cosine squared times sine x. Everybody can see that? So that's what I'm going to multiply everything by. So I multiply the first one, the cosine squareds are going to cancel, and I'm left with just sine x. Cool? I multiply to this one, and nothing's going to cancel. So I'm just going to have cosine squared times, I have two sines multiplied together, so that's going to be sine squared. Jane, are you okay with what I did there?
Why would sine cancel out?
Because it's they're both in the numerator,
Oh,
right? So they're just being multiplied together, as opposed to one being in the numerator, one being in the denominator, where they can cancel.
Wait, why did it, why did, when you multiply cos with the sine, why did only sine multiply with sine?
Because they're not like terms,
Oh.
right? Imagine if you had like x squared y times y, that'd be x squared y squared, right? Same idea here. Like the sine and the cosine are like different variables. Does that feel okay? So then we'll go to the denominator. So again, we're just multiplying by 1, so it just, nothing happens. And then when I do cosine over sine times cosine squared times sine, the sines are going to cancel, and I'm going to be left with cosine cubed. Oops. So far, so good? Okay. So next thing I'm going to do, I'm going to say, okay, is there like any algebraic thing that I can do here? And I see some algebraic stuff I can do, because I see that I have a common factor in the numerator, and then I see I have common factors in the denominator. So I'm going to start by factoring some stuff off and see what I get here. So if I factor off a sine x, and I don't know if anything's going to cancel or if I'm going to be able to do anything good yet, but I want to check. What I had there before might be just like as good as I can do. And it seems like maybe it was, right? I factored off that stuff, but it doesn't seem like there's anything else left to cancel. Let's go look at the answer key real quick and see what we wrote there, just to make sure. Which one was this that we're doing? 6, thank you. Oh yeah, okay. So yeah, there wasn't anything. What we had before was where we ended. So this answer that we have where we factored, or the answer before it, either would be appropriate. It doesn't matter. You haven't really changed anything in either one because no reducing happened or no combining happened. So like, they're the same answer. I just did the factor at the end to just double check there wasn't anything hiding in there that maybe could reduce. because when it's written as addition and subtraction problem, I can't reduce anything. When we factor, it turns into a multiplication problem, so maybe there's some stuff that could cancel, but not in this case. So either one of those two would be fine. Landon?
So like say hypothetically, your cosine on the bottom was to like the second power, or like the square.
You're talking about this cosine here?
Yeah, just like hypothetically.
Okay.
Would you be able to cancel it with the cosine numerator?
No.
Okay.
And the reason not is because they're both parts of an addition or subtraction problem. So it's either the whole addition and subtraction problem or none of it. So that, even if that was a squared, that wouldn't have mattered. Now, had this, instead of it being sine x, had it been cosine x up here, you could reduce like that, and that would be fine. But, Victoria.
For like, if one of you did like the back, why can't like the sine squared, that's like multiplying with the squared, cancel out with the sine that's normal?
Sure. And the reason is that they're parts of addition and subtraction problems.
Like the whole thing's part, like nothing's like, well, I know, but cosine, sine, are multiplying. Cosine, sine,
Right, but they're being added to some other stuff.
okay.
So if we think about, let's think about this problem. So if we have something like this, you wouldn't do that, right? You'd just be like, oh, you get 7 over, -1, and just do the arithmetic, right? Clearly, if we do this reducing, you end up with like 3 over -3, which is definitely not the same number. So, like, sometimes if you just make like a trivial arithmetic problem and just check, be like, oh, okay, if I reduce like that, do I still get the same thing as if I just multiplied everything out? That's sometimes helpful if you're like, can I do that or not? But I get what you're saying. But it doesn't matter that those things are multiplied together because they're also being added and subtracted. So it turns out that the addition and subtraction part is the part that really matters. Is that helping?
Yeah.
And this particular piece of like, when can I reduce a fraction, when can I not, takes a minute to kind of get to wrap your head around, right? Like we did a little bit of it last year when we talked about rational functions, right? But it's been a minute, and this is now another layer of going on, because instead of just x's and numbers, we have these sines and cosines and stuff floating around, so it's like a little bit extra confusion. But that question of when can I reduce and when can I not is a really important one, right? Because if you can't reduce correctly, like you can get all kinds of wacky answers. Okay. You guys feel a little bit better having had some questions and ran through some more of these things? Okay. Let's stop here and we'll do this homework quiz.